Hi and welcome back to R for BRFSS. I'm Jennifer, your instructor for this tutorial series. The last time we met, we wrapped up our segment on chi-square test. Today we're going to be cleaning some continuous data, and I'll give you an example of a t-test and how to resolve some issues when you also have missing data. And we're actually not working with an article today because, as it turns out, a lot of studies looking at BRFSS data only look at the categorical response options, so they're not dealing with the continuous data. But in cases where that might be of interest to you, for example, if you want to look at the average BMI, or you want to look at the number of fruit that people consume within a month. Okay, so looking at fruit intake over the month, working with continuous data might be interesting to you, but before you can work with that data, you have to clean it. So let me show you what I mean by that. Let's hop over to the CDC codebook. So I'm opening up the internet, CDC BRFSS 2017. We'll click on the first results and open up the 2017 BRFSS codebook. So one example of a continuous variable is body mass index. So that variable is called underscore BMI 5. And yep, so body mass index, and it's a value from 1 to 9,999, where it's implied that it has 2 decimal places. So if you wanted to analyze BMI as a continuous variable, what you would want to do then is divide this variable by 100. So I'll show you how to do that. Another continuous variable is alcohol consumption over a week or a month. So ALCDAY 5. It's not this one. It's this one. So this question looks at during the past 30 days, how many days per week or per month did you have at least one drink of any alcoholic beverage? So the values are coded as if the person responded in days per week, there's a 1 in front of the number of days per week. If they responded as days in the last 30 days, they put a 2 in front of days in the last 30 days. And then 777 is don't know, not sure. 888 is no drinks. 999 is refused. So in this case, if you want to look at days per week, you would have to first subtract 100. If you wanted to look at days per month, you would have to subtract 200. And then if you wanted to kind of standardize this days per week to days per month, you would multiply times 4, assuming that there are 4 weeks in a month. So you could also multiply times whatever 30 divided by 7 is, 4 point something, to get the exact number over 30 days. But as a rough estimate, you could first subtract by 100, then multiply times 4 for 4 weeks to get the estimate for the days over the last 30 days. All right, and there are a couple of other variables that have a similar layout. For example, fruits 2 asks the question in a similar way, where days per week has a 1 in front of it, days per 30 days has a 2 in front of it. So you'd have to do a similar calculation and conversion to work with. So this is still alcohol days, but there's a variable called fruit, and it's this one. Okay, so anyway, here they put a 1 in front of days, a 2 in front of weeks. And then for 300 is less than once per month. Anyway, you can see that these are technically continuous variables, but they have some weird conversions and perhaps calculations that we need to do before we can work with this data. All right, and another one, a pretty simple example, is asking about the number of children in the household. So this one's really easy. Either you have between 1 and 87 children, or you have none or refused. So in this situation, we can just only look at the values between 1 and 87. We don't have to do any math on this continuous variable to work with it. We just have to make sure that we specify that 88 and 99 are not the number of children. Okay, so let me show you how we're going to do that. I will open up a new R session, let's set our CRAN mirror to the cloud, okay, and set our directory, change directory to the desktop, R for BRFSS. Okay, today we're working with the tidyverse and the survey package. So let's load library, tidyverse, and library survey. Okay, so the first thing we have to do is read in our California Girls 17 CSV file that we subset way in the beginning of this tutorial series. So let's call that California Girls 17, put in the assignment arrow, read.csv, in quote marks, California underscore girl 17.csv, end quote, comma, header equals true. And we can glimpse that data file just to make sure it read in correctly. Glimpse California Girl 17. And I see variables, that's good. And we still have all 9,355 of our observations from the state of California and all 240 variables. All right, so I selected a couple of variables that are continuous variables that we can clean for today. So they are these 5. So I wanted to look at that variable called children, BMI, alcohol, like alcohol consumption, fruit consumption, and this one, exer-oft1 is exercise. So let's just look up that variable so we know what it means. Exer-oft1. How many times per week or per month did you take part in physical activity? So yeah, so those are the continuous variables that we'll use as examples for cleaning. I also wanted to include some demographic variables as well, just because I'll give you an example of how you can set these demographic variables, how you can set the reference level for these demographic variables in case you want to use your continuous variables in a linear or logistic or whatever regression model. All right, so that would be a situation where we would also need to work with some demographic variables, and then I have our weighting variables in here as well, just because we're working with the weighted BRFSS survey data. So we'll set our survey design. All right, so of these variables, we're going to set an object called CG17 underscore constvar for California Girl 17 continuous variables. And we'll start with our California Girl 17 main data set, and then subset it by selecting these variables which I just described to you. So let's go ahead and copy and paste that in. And we'll take a glimpse at CG17 underscore continuous variables. Yep, so we have 12 variables. We still have all of our observations. And as you can see, let me just rerun that again so we can see the full length of that. And then maybe I should make this window a little shorter and longer. Okay, there we go. Yeah, so as you can see, just right off the bat from the children variable, we already see we have some 88 values, which, if I'm not mistaken, that means that there were no children. Let's just double check on that. Okay. Children. Yeah, so 88 means none. So already right off the bat, we can tell that we have a lot of people responding that they have no children. But if we wanted to, for example, take the mean on this children variable, it would account for 88. So we would get a lot of values, a lot of people reporting that they had 88 children, and that would really affect our mean. So we need to take care of that. As you can see, the BMI is, this is like a BMI in the thousands, right? So they have a BMI of 3,018, which is really, this person has a BMI of 30.18. So we have to divide all of those by 100. For this alcohol variable, here's a 1, 1. So these responses are days per week. The responses with the 2 in front of them are days per month, so we have to clean that. Same thing for fruit and exercise. And then these are our demographic variables, and these are our weighting variables. Okay, so let's get started with the easiest variable to clean, in my opinion, is this BMI variable. So what we're going to do is in our data frame, CG17 underscore continuous variable, we're going to target that BMI x underscore BMI5 variable. So we're going to look at this column, put the assignment arrow to reset this column to this column, but divided by 100. So this is pretty simple actually. We're creating a column called x underscore BMI5 on the CG17 underscore continuous variable data file, but it will contain the contents of that variable divided by 100. So if we go ahead and run that, now if we glimpse our data file again, we can see this BMI variable has decimal points in it because we divided by 100. So whereas before, previously, the first person had a BMI of 2,685, now they have a BMI of 26.85. So that worked. That's good. Next, let's look at that variable for the number of children. So in this situation, we basically want to keep everything the same except for, let me take you back to the codebook. So we want to keep values 1 through 87, but get rid of anything that's greater than 88. So the none or refused. And then in the analysis, it will just treat the blank values as missing data, so we could account for that as well. But in terms of cleaning this data, what we want to do is simply replace everything in this variable. So within this function, within the replace function, we are setting that variable to the object called x. And we want anywhere that x is greater than or equal to 88, we want it to be replaced with 0. So let's run through that line of code. In this children variable on our continuous CG17 continuous variable data file, assignment arrow, we want to replace this variable, which we've called x inside of our parentheses, where anything greater than or equal to 88 is replaced to 0. All right, so let's run that as well. And then when we glimpse our data file again, yeah, we see anywhere there's children. So on the first line, now we see anywhere that there was 888, there are zeros instead. Rather than 888, actually 88. So here we see a bunch of 88s in the data file before, and in their place now we see zeros. So that's good. Now we've cleaned 2 continuous variables. Those are the easy ones. The next ones are kind of hard because they put 1s and 2s in front of, in front of either weeks or months. So we kind of have to do a bit of finagling, I think, to make our data make sense. And so what we can do, first I'm going to show you the long version, then I'm going to show you the quick version. So what you could do is first you could start with your data file and then filter out the responses, for example, so the responses for this alcohol variable between 101, so greater than or equal to 101, and less than or equal to 107. So that's this range of values. Those are the values where people responded the number of times per week. So we could look at just those values and then mutate them by setting that variable to that variable minus 100, because first we have to remove that 1 in the 100 spot, so we have to subtract 100, and then if I'm interested in looking at this data that's the days per week compared to the other data that's the days per month, I have to convert this data to days per month. So to get days per week to days per month, I multiply by 4, assuming that there are 4 weeks in a month. And again, you can do whatever 30 divided by 7 is, so 4 point something, if you want to get the exact conversion between weeks to days over 30 days. But I'm just doing a rough conversion, so days per week times 4 weeks is approximately days per month. All right, so we could start by doing that. So let's run that and see how that looks. Okay, and now we have a new data file called A, which contains our data file, the CG17 underscore continuous variables, filtered for these values, and this value mutated, so minus 100, then times 4. So then if we look at this variable, alcohol day 5, in the new A data file, A $ALC DAY5, we see that we have 1,500 observations where people reported their response in the number of times that they drank in the last week. So 1,500 people had a drink in the last week, and these numbers that you see here are that number times 4. So for example, this 8 right here, so this person, their response in the codebook would have been coded to 102. So we subtracted 100, so in a week they had 2 drinks, times 4 weeks is 8 drinks. All right, so now we have 1,500 responses that we've normalized to the month, okay? So now let's look at the responses that people reported the number of drinks in the last month. So again, we start with a continuous CG17 continuous variable data file, filter out the responses where they reported their alcohol between greater than or equal to 201 and less than or equal to 230. So between 1 and 30 days in the last month. And we're going to mutate that variable where we simply subtract 200 from their response. Okay, so if they reported 201, that means that in the last 30 days they had 1 drink. So we just want to subtract 200, so our response is 1, or our final answer is 1. So again, we're setting this to the object called B, just so we're kind of creating a new data file where this data, this calculated data for a continuous variable is stored in this data file called B. So we'll run that also, and let's look at B, alcohol day 5. So now we're looking at that column in the B data file where the responses filtered between 201 to 230 have been mutated to subtract 200 from each response, so we get the number of drinks consumed in the last 30 days. And of this, we get over 3,500 people who responded that they consumed at least 1 drink in the last 30 days. And so these numbers here are the number of drinks they had in the last 30 days. So for example, the last person only had 1 drink in the last 30 days. The second to last person had 20 drinks in the last 30 days, and so on and so on. All right, but we still have some missing data, right? Because let's go back to the codebook and look at that variable, alcohol day 5. Where there's a response 777, 888, 999 are missing, that's data that we don't want to include this value 777 or 888 or 999 into any of our calculations. So if you wanted to take the average, right, you would want to set all of these to, I'm going to set them to 0 just so that they don't factor in to any calculations that you would do on the continuous variables later. So again, we start with our continuous variable data file, filter out the responses greater than or equal to 777, and just mutate that variable to equal 0. And we're going to do the same thing on missing data. So again, start with our continuous variable data file, CG17 continuous variable, filter out where the alcohol day 5 responses are missing, so is.na, so where we have missing data, mutate that variable to equal 0. So I'm just going to run these 2 lines of code together. And let's look at C $ALCDAY5 to take a look at that mutated data, and we get all zeros. That's good. So there are over 3,500 people again who responded something greater than 777. So either don't know, not sure, they had no drinks, or they refused. And then if we look at D, which is our missing data, so D $ alcohol day 5, we also get all zeros, which is good, about 600. So 600 people had missing, didn't respond. 3,500 people basically said none or they refused. 3,500 people reported their number of drinks in the last 30 days. And 1,500 people reported their number of drinks in the last week. But we converted everything so that we can look at the number of drinks over a month. All right, but now we have 4 different kind of subset data files. So what we want to do is bind these 4 subset data files together, which we will do using rbind. So we call this A, B, C, and D. So we're going to set a new object called Y, where we bind together those subset chunks A, B, C, and D. So copy it, and these are actually new data files, A, B, C, and D, that contain all of the variables actually in the California Girl 17 data, that contain all of the variables in the continuous variable data file, but specifically have this alcohol day 5 variable mutated to whatever we've mutated it to. So we're going to bind all of those mutated data files together. And when we do that, let's glimpse at Y. So now we have our whole continuous variable data file, but on our alcohol day 5 variable, we have our responses about alcohol consumption coded correctly to look at the number of drinks in the last 30 days. So if we look specifically at Y $ALCDAY5, you'll see that all of our responses are here, but as you can tell at the bottom, because of the way we bound the rows together, all of the zeros are stacked at the bottom, and actually the order of this data frame now is like A, B, C, D. And that's a problem because it got disorganized on the PSU, so that's the primary sampling unit, that's like the respondent's ID. So you can see here, it just mixed up the answers. So this is the 2nd person, this is the 5th person, this is the 10th person that responded to that survey. Whereas if we scroll up, I don't really want to scroll. So let's just, let's look at let's glimpse California Girl 17 _ continuous variable. When we look at our original data file that we're working with in today's tutorial, the PSU is organized in the correct order. So the primary sampling unit starts with 1, then 2, then 3, 4, 5, 6, 7, and it's in order throughout the whole data file. But again, when we glimpse Y, that PSU is disorganized. So if we want to be consistent in our analysis and keep our primary sampling unit, in order, what we can do instead is to arrange this data file Y by the PSU variable. So we'll call that Z. We'll just create a new data file called Z, where we arrange this data file Y according to the primary sampling unit. So we're putting the respondent IDs back in order. So when we do that, let's glimpse at Z. And we can see here our PSU is back in order. So this is good. So now this data file Z is basically our CG17 _ continuous variable data file, but it has the question about alcohol consumption is standardized to the number of drinks per month. So we successfully mutated that variable. We've cleaned up that continuous data. And we can confirm that by looking at both the tail of the Z data file and the CG17 _ continuous variable data file. We can confirm that these data have been mutated correctly. So for example, in the original California 17 _ continuous variable data file, the person responded 202, and for all responses that are the 200, so those responding per month, we just subtracted 200. So in our new data file Z, we get that answer to be 2. So that person had 2 drinks per month. So that's right. In the original data file, the next 2 people responded 888, and we wanted to set that to 0. So we did that right. That's good. The next person originally responded 102, so that means that they had 2 drinks per week. So we subtracted 100 and then multiplied times 4 to look at the number of drinks over a month. So we got 8. And again, 220 minus 200 is 20. 201 minus 200 is 1. So that's good. So our mutation is correct, and it looks like it's in the right order. Let's just confirm again by looking at the head, in case you're not convinced yet. So again, so 888 converts to 0, mutates to 0, 101, so they had 1 drink in a week, times 4 weeks is 4. A couple of more 888s, 103, so they had 3 drinks in a week, times 4 weeks is 12 drinks in the last 30 days. 220 minus 200 is 20, so in the last month they had 20 drinks. Okay, so this is one way to mutate your continuous variables and clean it up to be able to use it in further analysis. But that is quite a lot of work, and we can take a shortcut by using this function called case when. So case when allows you to look at multiple subsets of data in one line of code. This looks like several lines of code, but that's just because I broke it up so it's clear to see. But really, this is one line of code, right? So again, we're starting with our CG17 underscore continuous variable data file. We're not filtering, right? Because previously we filtered each of the data files out, which ended up giving us 4 different variables, 4 different data files that we had to bind together. So now we are not filtering, we're jumping straight to mutate, and we're mutating this variable in cases when the variable lies between 101 and 107. Then we want to take that variable minus 100 times 4. All right, then put a comma. And then in cases when that variable lies between 201 and 230, we want to take that variable minus 200. In cases when that variable is greater than or equal to 777, we want to mutate that to 0. In cases when that data is missing, we want to mutate it to 0. And then we have 2 parentheses here just to close the parentheses, because we have an open parentheses here and open parentheses here. So anywhere we open a parentheses, we have to close a parentheses. Okay, so let's run this. We're just calling this ZZ because I'm running out of letters and I'm forgetting what we're setting our objects to. So here we had Z. Now I'm just calling it ZZ. It doesn't matter. So when we run that, and then we take a look, so we run that, and then we can set the contents of this ZZ variable. We can replace the contents of this alcohol day 5 variable in our existing data frame with the contents of this alcohol day 5 variable from the ZZ data frame. So we're just basically putting this mutated, cleaned continuous data onto our existing data file. And now let's glimpse CG17 underscore continuous variable again. And when we look at the alcohol day 5, we're seeing, okay, so remember, 040012. And then when we had this previously, 040012. So this is 040012. This is that Z data file that I just showed you the long example for. 040012. And this is our continuous CG17 continuous variable data file, 040012. Right, so we mutated everything correctly in both data files, but when we use this function called case when, we can do it all on one line. We don't have to filter out. We don't have to bind our like chunks together and then reorganize them. We just, mutate this variable in the case when this exists, and this tilde means like in this case, then do this. All right, so we have written the code for that for the fruit variable and the exercise variable. Yeah, so for the fruit variable, let me just walk you through that code. For fruit, let's look at the code book. Fruit2. So for this variable, the response options were in days was 101 to 199, weeks was 201 to 299, 300 was less than once per month, 300 to 399 was month per year, and then etc., etc. All right, so we want to mutate this data so that we're looking at the number of times per day that fruit was consumed over the month. So we're looking at times. We want to look at times per month. All right, okay. So in order to do that, we start with our CG17 continuous variable data file. Then we put in a pipe to mutate this variable, fruit2, in the case when fruit2 is greater than 200. Then we want to subtract 100 and multiply times 30. I think I said greater than 200, so in the case where fruit is less than 200, so that's here. So when they report their fruit intake in the number of times per day, then we want to subtract 100 and multiply times 30. All right, so if they responded 101, that means that they had one piece of fruit per day. So we subtract 100 times 30 to get 30 pieces of fruit over 30 days. All right. So in cases where their response to fruit was less than 200, mutate that to fruit minus 100, then times 30. When their response was between 200 to 299, so greater than or equal to 201, and less than or equal to 299, then subtract 400 and multiply times 4. Because that response option is number of times per week. So first subtract 200 to get rid of this 2 in the hundreds place, and then assuming that there are 4 weeks in a month, multiply times 4. So fruit minus 200 times 4. In cases when fruit is reported to be greater than or equal to 301 or less than or equal to 399, so that response is times per month or year, then we're just simply subtracting 300. All right, so between 301 and 399, fruit minus 300. If they responded fruit equals 300, so that was less than once a month, or if they responded fruit being greater than 555, so that's never, don't know, not sure, or refused. So for 300 and 555 through 999, then we want to set that equal to 0. And then if there's any missing data, we'll just go ahead and set that equal to 0 as well, so it doesn't mess up our means. And then we can also, when we're calculating, when we're running tests on continuous data later, we can also specify to remove the missing data. But this is just kind of like a fail-safe. I usually set the missing data to 0, and then also account for it later. But anyway, so let's go ahead and run this line of code. We're setting it to ZZ1. Again, that's just a random object name because I'm losing track of my object name, so I'm just calling it ZZ1. All right, so we've mutated that data in the cases when, etc., etc. And now let's assign this variable that we just calculated. So ZZ1 $fruit2 will fill the contents. We'll use the contents of this variable to stand in place of the contents of that variable currently as it is in our data file. Right, so we're putting this data into this column. So let's run that. Let's glimpse CG17 underscore continuous variable. All right, and then when we look at the fruit, you see we have these numbers now, which are, I should have I should have showed you this before I calculated it out. So Oh well, anyway, these are the numbers normalized per the times of fruit consumed, number of times fruit was consumed in the last 30 days. All right, so let's look at that variable as a whole. Continuous variable CG17 underscore continuous variable $sign FRUIT2 fruit2. So if we look at that, if we look at this, the whole column, yeah, we have all of our observations, and this is the number of times people consumed fruit in the last month. So this person reported 90. I don't know if you can see that with my video there. So this person consumed 90 pieces of fruit in the last month, so that's approximately 3 pieces of fruit per day. This person reported 180 pieces of fruit in the last month, so that's 6 pieces of fruit per day. Yeah, okay, so that's the variable about fruit intake in the last 30 days. Finally, let's look at the variable for exercise in the last 30 days. So let's look at that in the code book. Yep. So these values are times per week is 101 to 199. Times per month is 201 to 299. Don't know, not sure is 777, and refuse is 999. So we're doing the case when function again. All right, so we'll just set this object to ZZ2. Starting with our CG17 continuous variable data file, put in a pipe, then mutate this variable extra-oft1 in cases when that variable is less than 200, then subtract 100 and multiply times 4, right? So 101 to 199, so if they reported 101, that means they exercised 1 time in that week, and times 4, assuming there are 4 weeks in the month. So that would mutate that value to 4. All right. So, and then if they reported like 102 minus 100 times 4 would be 8. Okay, so if yeah, so then in cases when exercise is less than 300, simply subtract 200 because the value for that is times per month. So between 1 to 99 times per month minus 200 is the number of times per month. And then in cases when that variable is greater than or equal to 777, mutate it to 0. For missing data, also mutate it to 0. So we'll run that. And before I assign this variable to our CG17 continuous variable data file, let's take a look at CZ2 $sign extra-oft1. So we're just looking at this column in the ZZ2 data file that we just created. This is our mutated variable. All right, so that's that. That looks like, it looks like all of them are between 0 to 30, right? Just by looking at it quickly. And then if we look at this variable in the CG underscore 17 underscore continuous variable, right? So you can see there's a marked difference. So let's just remember this last value is 103. So this means that they exercised 3 times in the last month. So minus 100 times 4. Minus 100 times 4. So in the ZZ2 data file, then this value of 103 should be 12. So let's check that again, and it is. Our last value is 12, whereas in the other one it was 103. Okay, so we cleaned that continuous data. Let me just go ahead and assign that column to our CG17 underscore continuous variable data file in the place of the column that's already there. And now if we take a glimpse at our CG17 underscore continuous variable data file, we'll see that, children, BMI, alcohol, fruit, and exercise. So these are our cleaned continuous variables. Now, in case you wanted to do regression analysis and you had some demographic variables that you were working with, you would want to also clean clean your demographic variables, and then set a reference value for them. So we've done this before, setting our values as a factor, and then recoding that variable based on whatever. So for sex, in the codebook, 1 is male and 2 is female, so we're setting 1 to M and 2 to F. Let's say we also want to look at income, so we set that as a factor and recode that variable to the different income levels. So one is less than $10,000 per year, 2 is between $10,000 and $15,000 per year, 3 is between $15,000 to $20,000 per year, so on and so forth. So we're just recoding those values. If we wanted to look at education, we would set it as a factor, then recode that variable to 1 is not having completed kindergarten, 2 is having completed elementary school, 3 is some high school, 4 is high school or GED, 5 is some college, 6 is a college grad, and then setting our defaults and missing values to NA. We did that for income as well, defaults and missing values to NA. Let's say we wanted to look at year, so we set that variable as a factor, then recode the response values to the different age categories. And again, setting default and missing values to NA. So let's just run this code for cleaning up our categorical variables. So these are our demographic factors. Run all of those. And here we get a warning message that missing values were introduced by coercion. So that just means that that it recoded. Let's see. Did I set that to numeric? No, I set it as a factor. So I guess in this situation, well, let's look at our data file now. Let's see what that variable actually looks like. So glimpse cg17 underscore continuous variable. All right, that was, which one was that? That was the income. Yeah, so it looks like it recoded the values correctly as we set them to, but it shows up the missing data here. So probably what happened is, what's that variable? Income 2. Let's just take a look at that in the codebook. Income 2. All right, and that's, oh, okay, so I think because we coerced 77 and 99 to missing data, and then there's blank data here as well. So it just, I don't know whatever happened, but it looks like it did recode correctly. So I'm not going to worry about that for now. Right, anyway, so this is our California Girl 17 continuous variable data file where we have our continuous variables cleans. We also have our demographic variables cleans. And here we have our weighting variables finally at the end. Okay, so we're almost done. I just wanted to show you a couple of different things. So assuming that you were working with demographic factors and you wanted to set a reference level, so let's say for the sex variable, you wanted to set your reference level to female, for example. So you use this function called RELevel, reference level. Then you name your variable and set the reference equal to whatever, so to female. All right, and I just did that over the other 3 demographic factors. So for income, we set the reference level to an income of greater than 750,000. For education, we set the reference level to the reference of a college graduate. For the age variable, we set the reference level on this variable to the reference of the people who are between 18 to 24 years old. So if you're doing regression analysis or any analysis that requires some reference variable, this is how you set your reference level. Otherwise, R will just, I'm not sure how R assigns reference levels automatically, but it will assign a reference level to some response in your variable, but it might not be the one that you wanted it to be. All right, so this just gives you some control over setting your reference values for each variable. So we'll just go ahead and run that as well. We're not going to be doing anything with these reference levels today, but just for your future information, this is how you would do that. And finally, I told you that I was going to give you an example of a t-test. So because we're working with the weighted BRFSS survey, we have to set our survey design, which we've done before. So this function, survey design, is from the survey package. We set our data. We set our ID to ~1. The strata is ~x_STSTR, and our weights are that LLCPWT variable, so ~x_LLCPWT. So now we're setting our survey design. And let's take a glimpse just to make sure. Glimpse CG17 underscore continuous variable underscore survey. All right, so we have all of our observations, and this, one variable refers to the fact that it's our survey design. This is our data frame. This is good. We set our survey design correctly. Okay, so if you wanted to do a t-test using the survey package, using our weighted survey design, the function is survey t-test, so SVY t-test. What you do is you set your formula. So for example, if we wanted to look at BMI by sex category, so you set your formula, and then the next argument is your survey design. So let's run that. And when we run that, we get our p-value. So it looks like BMI by sex is statistically significantly different because the p-value is 0.01257, and the sample estimate, so the difference in means, is about half of a BMI points. All right. So this gives you the p-value, but it doesn't give you the means or the confidence intervals or whatever. So to look at that, you do survey by. So we're looking at the factor BMI 5, so ~x_BMI 5, by ~sex, so by the sex factor. This is our survey design. We want to look at survey mean. So we want to look at the mean of BMI by sex category from our survey design. And we want to also look at the variable types. Maybe we want to look at the standard error, or the confidence interval, or the variance. And here I have na.rm equals true because in our mutated, cleaned up BMI continuous variable, we do still have some missing data. So we want to tell R to remove that missing data from the analysis. But let's not remove it from now. Let's see what happens when we just run this line of code without removing the missing data. So when we run that, we get a bunch of missing data because we still have missing data in this variable, right? We've cleaned this continuous variable, but there's still some missing data. So what we have to do is put the argument na.rm equals true. That means remove missing data from the calculation. And now we get our response. This is good. Okay, so the average BMI for females is 26.87. The average BMI for men is 27.34. These are the standard errors, lower and upper limits on the confidence level, and the variance. And these means are from the survey design. So this is the weighted survey mean of BMI per male and female respondents. Okay, so that's the only example I wanted to give you because, as I said, I wasn't able to find an article necessarily that worked with continuous variables. So I didn't want to start like making up some statistics and doing something wrong. So if you are working with continuous data, and you're interested in continuous data in the BRFSS. Anyway, if you're working with continuous data, definitely partner with a statistician that can help you make sure that your test assumptions are correct, that you're applying the correct statistical methods to whatever your research questions are. So this was t-test. If you are, for example, interested in doing an ANOVA, that function is, you can search for ANOVA.SVYGLM. So this is the documentation for doing an ANOVA using the survey package, so the weighted survey design. Another common one would be a regression analysis. So that's SVY-GLM for survey generalized linear model. And this is the documentation for that. All right, and then I showed you this quite a long time ago, but you can just search for the survey package in R directly and open up that PDF file. And this will tell you all of the tests and analyses that you're able to do with this package. And the reason why you use this package is because there are equivalent base package functions for t-test, ANOVA, GLM, but they don't account for the weighted survey design. So every time we work with our BRFSS data, we set the survey design, and that survey design object is something special. So some functions just can't deal with that survey design, but the survey package does. So that's why we've been using the survey package, in case you forgot or maybe you didn't know. All right, so there are a lot of things that you can do with the survey package if you're, working with continuous data or categorical data. Anyway, if you're doing any research at all on this data, please work with a statistician. Yep. Okay. So I'm sorry. That was kind of a little awkward. I'm getting more awkward as the days go by. But anyway, that's what I wanted to show you today, is that BRFSS does have some continuous variables, but you have to do quite a bit of cleaning before you're able to work with them, which is probably why most publications on BRFSS data look mostly just at the categorical responses, so prevalence estimates or logistic regression, rather than looking at population means. Okay, so that's it for this tutorial. I'm closing my R session. I'm not saving the workspace image. I'll just close out the internet, close out my code as well, and then I will end the video here. All right, thanks for joining me this time. I'll see you back here next time. Yep, okay, bye.